In this video, we are going to work on rational functions. Usually you are given an equation and you have to find the asymptotes. But on the test, your teacher is probably going to flip that on you. They'll give you the asymptotes and ask you to find the missing numbers in the function itself. It feels a little backwards. So let's see if we can solve this step by step. We're starting with this function here that has two unknown constants, a and b. We have our horizontal and vertical asymptotes, and we just need to use those as our givens to unlock the rest of the equation. Before we even touch the algebra, let's just look at the structure for a second. We have x to the power of 1 on top and x to the power of 1 on the bottom. This is our classic linear over linear setup. It's the most common version of this problem, and it actually gives us a really nice shortcut that we'll use in a minute. Let's start with the vertical asymptote. This happens whenever the denominator equals 0. Now let's really think about what that means. Well, as x gets closer and closer to a specific value, the bottom of your fraction gets smaller and smaller, and it becomes so tiny. Now what will happen is, if you divide a number, say 5, by something incredibly small, like 0.00001, your result explodes towards a massive number, right? And let's draw this on a graph. As the x gets closer to the value that makes the denominator close to 0, the value of y will explode to an infinitely large number. And that explosion creates a vertical wall on your graph. It's a boundary that the function approaches but can never ever actually cross. And that's what we call a vertical asymptote. So this vertical wall or vertical asymptote is located wherever that x makes the denominator equals 0, right? So we're told our vertical asymptote is at x equals -4, and that means if we plug -4 into that denominator, the whole thing has to crash and equals 0. And let's try that out. So b multiplied by -4 minus 8 equals 0. Now we just solve for b. Make the 8 over and we get -4 multiplied by b equals 8. And divided by -4, and there we go, b equals -2. Okay, so we are halfway there. Now let's look at the horizontal asymptote. To find this, we want to look at the and behavior. So basically, what happens to this graph when x becomes a massive number, like a billion or a trillion? If you have a billion on top and a billion on the bottom, that 24 and that -8 don't really matter anymore. They're just noise, right? They're not changing the value in any meaningful way. So we're essentially left with ax over bx. The x cancel out, and we're left with just the ratio a over b. And we are told that the horizontal asymptote is y equals 3. So that means a over b must equal 3. But we already know that b is -2, so if a divided by -2 equals 3, we just multiply them together and find that a has to be -6. Let's just pause and see if that actually makes sense. Our final function would be fx equals -6x plus 24 divided by -2x minus 8. If we look at the coefficients, -6 divided by -2 is +3, which is exactly our horizontal asymptote. So it checks out. If you were to pop this into a calculator or decimals, you'll see the perfect vertical line at -4 and that horizontal floor at 3. Hopefully you found that helpful. If you are studying the advanced functions and want more of these walkthroughs, hit subscribe and I'll see you in next video.